Picture this. You're idly scrolling through a DNA test app over your morning coffee, and it casually informs you that you're 1.8% Neanderthal. Sounds quirky, right? Like a fun fact for a party. But now, really imagine that tiny scrap of code. That minuscule percentage wasn't just a random genetic hiccup. It was traded piece by priceless piece during a sprawling 7,000-year-long genetic street market that quite literally rewired every single human population outside of Africa. We're not talking about wars or grand empires rising and falling. This was something far more fundamental. It was a long, slow biological handshake across species lines, a profound exchange that altered our skin, influenced our moods, reshaped our susceptibility to disease, and even redrew the map of human migration. Are you ready to meet the ancestors you never knew you had? Because they're closer than you think. 50,000 years ago, the planet didn't quite look like the unified world we know today. Instead, from a human perspective, it resembled two neighboring countries that had somehow never agreed on where their shared border lay. South of the vast, sun-baked Sahara, our direct ancestors, Homo sapiens, were thriving. They were typically tall, slender, and, for the era, remarkably high-tech, living in dynamic, restless groups. But north and east of the Mediterranean, another species had already mastered survival through two brutal ice ages. These were the Neanderthals, physically robust, with heavier brows and barrel chests that spoke of immense strength. We call them Neanderthals. What they called themselves, we'll never know. But make no mistake, they were sophisticated. They possessed language, controlled fire, and adorned themselves with jewelry. For millennia, these two populations lived tantalizingly close, yet rarely did their paths truly intersect. That is, until the climate flicked a switch, and the African side of humanity began its epic wander. This wasn't a fleeting encounter, a mere blip on the evolutionary radar. Geneticists now pinpoint the main window of interbreeding to approximately 47,000 years ago. And here's the truly mind-boggling part. That window stayed wide open for roughly 7 millennia. Just think about that. 7,000 years of seasons, of generations born and raised. Every single generation offered another chance for teenagers, perhaps curious and adventurous, to sneak off, trade songs, share stories, and, yes, trade DNA. The chromosome evidence paints a fascinating picture. For instance, East Asians today carry about 20% more Neanderthal segments in their genome than Europeans do. This suggests the genetic exchange kept flaring up as our ancestors pushed further and further east. This wasn't a one-night stand on the plains of the Middle East. It was a continent-spanning, multi-generational romance. There's even evidence of smaller interbreeding events as far back as 100,000 years ago, hinting at a more complex story than we ever imagined. So, what was the first immediate payoff of this ancient merger? Immunity. Think about it. Our African ancestors were venturing into a germ gauntlet. Europe and Asia teemed with novel parasites, fungi, and viruses that Neanderthals had been battling for 500,000 years, evolving robust defenses. When modern human chromosomes mixed with Neanderthal-derived genes crucial for fighting infections, our immune systems got an invaluable upgrade. We could recognize and fight off these foreign pathogens more effectively. You know that friend who never seems to catch the office flu? Part of their superpower might be courtesy of an extinct cousin who coughed in a cave tens of thousands of years ago, passing down a vital piece of biological armor. It's like inheriting a bulletproof vest from a veteran of a microbial war. The second profound payoff revolved around vitamin D. Our African ancestors arrived in Eurasia with dark skin, a perfect adaptation for intense equatorial UV radiation. But move north, and the sun becomes stingy. Dark skin becomes a hindrance, making it difficult to synthesize enough vitamin D for bone health and immune function. Neanderthals, however, had already adapted. They evolved lighter skin tones, freckling, and even red hair. When modern humans and Neanderthals crossbred, their offspring gained the crucial ability to soak up scarce sunlight more efficiently. This wasn't about aesthetics, it was survival. These genes also tweaked hair texture, giving many Eurasians the thick, straight hair that's incredibly effective at shedding cold rain and snow. What we might now consider a beauty product was, back then, a vital survival tool. But, as with any grand contract, there are hidden costs. Flip that Neanderthal contract over, and you find the fine print. These ancient genes also left us with predispositions to certain modern ailments. We see increased risks for autoimmune diseases like lupus, and even the common annoyance of hay fever. There's also evidence of a tendency towards depression or anxiety in some individuals. Perhaps most strikingly, one cluster of Neanderthal genes on chromosome 3 has been strongly linked to increased COVID-19 severity. Another cluster raises the risk of type 2 diabetes, especially with a modern diet. Natural selection is a pragmatist. It kept the useful Neanderthal bits. But evolution is also messy. It is like wanting the powerful sports car engine but accidentally getting a fragile suspension system along with it. We are, in a very real sense, still navigating the trade-offs of an ancient genetic bargain that continues to shape our health and well-being today. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into our shared human story. Here's a wild thought. Without a little help from our ancient cousins, the Neanderthals, Homo sapiens, might never have left the cozy corners of the Middle East. We could have been stuck, looking out at the harsh Eurasian winters, wondering if we'd ever make it, but we didn't get stuck. Why? Because we borrowed some of their genetic superpowers. This wasn't just a minor tweak. Armed with these Neanderthal genes, upgrades for our immune systems, adaptations for lighter skin in less sunny climates, we pushed forward. We conquered the frigid Siberian plains, crossed the vast Mongolian plateau, and even ventured across ancient land bridges into entirely new continents. That Neanderthal DNA wasn't just a fun fact. It was the biological engine for the greatest expansion in mammal history. It gave us the resilience to thrive. Every major step non-African humans have taken, from painting masterpieces in the Lascaux caves to sending rovers to Mars, stands on the shoulders of this hybrid genome, co-written during those pivotal 7,000 years. Now, you might be thinking, this sounds cool, but how do we actually know all this? Well, this isn't just a fun theory. The game changed forever in 2010 when scientists at the Max Planck Institute in Harvard managed to sequence about 60% of a Neanderthal genome from ancient bones. It was a massive breakthrough. When they compared that ancient DNA to modern human genomes, certain segments matched up perfectly, like a genetic barcode proving our shared history. Since then, massive projects like the 1000 Genomes Project and the UK Biobank have confirmed this over and over again across countless populations. The evidence is overwhelming and consistent. We're not talking about a few isolated cases. This is a clear, widespread pattern across all non-African people, and it gets even more complex. The discovery of Denisovan DNA in some Asian populations shows that our ancestors had a rich and interactive social life. It paints a beautiful, complicated picture of ancient human connection. So the next time you're slathering on sunscreen because you burn easily, or you start sneezing when the pollen count goes up, or you feel that sugar rush after a few too many cookies, just pause for a second. You're not just dealing with a modern problem. You're reading the footnotes of a 50,000-year-old conversation written directly into your cells. The Neanderthals as a separate group might be long gone, their caves now silent. But they never really left. They just merged into the crowd, becoming a permanent part of what it means to be human today. When you look in the mirror, you're seeing a reflection of their legacy, in the way you look, in how your body fights off germs, and even in that deep-seated desire to explore and see what's over the next hill. We often think of agriculture or the Industrial Revolution as the big turning points for humanity. But maybe the most important moment happened much, much earlier. It was a quiet, intimate biological exchange, a 7,000-year-long secret that rewrote the destiny of billions. So, the next time someone tells you that you have a certain spark, you can smile and say, thanks. About 2% of it is a 50,000-year-old surprise. We are all connected, not just to each other, but to a vast and fascinating ancient family tree. What part of this incredible genetic story blows your mind the most? The immunity boost that helped us conquer new lands, The sunskin deal that changed our very appearance, or the subtle modern-day glitches that remind us of our ancient heritage? Drop your answer below in the comments. And if you're eager for more tales hidden deep within your cells, hit that like button, subscribe to the channel, and I'll see you in the next chapter of the astonishing code you carry.